Hello, this is a problem from Openstax Physics Textbook Volume Number 1, Chapter 4. It's an example problem 4.8. Here, a tennis player hits a ball into the stands at 30 meter per second. So the 30 meter per second is the initial velocity and at an angle 45. It's shown in the figure. So the initial velocity is 30 meter per second. Angle is 45 degree from the x-axis above the horizontal. On its way down, the ball is caught by a spectator 10 meter above the point. So you can see this is the spectator. From the point of this, like the ball is hit at this point. From there, it is 10 meter above. So calculate the time it takes the tennis ball to reach the spectator. So how much time it takes to reach from this point to this point. What are the magnitude and direction of the ball's velocity at impact? So we need to find the velocity at this point. Okay, its magnitude and direction. Direction means its angle. So first what we need is an XY coordinate system. This is the X coordinate and Y coordinate is shown here. Initial position of the ball is 0. So we said that's the origin. X0 is 0. And initial position of y coordinate is also 0. Y0 is 0. And this is the place where the ball is caught. Yt. After time t, the coordinate of the ball is yt. And this 10 meter height, right? It is caught at 10 meter height. That means yt minus y0. That is 10 meters. Okay, 10 meter is yt minus y0. This position minus this position. Now we need to, initial velocity is 30 meter per second. We need to find the x and y components. So the x component is v0x, which is 30 cosine 45 because angle is 45 degrees. And the y component is v0y is 30 sine 45. So we know now the initial velocities of the x and y components of the ball. Now acceleration due to gravity in the y direction is minus 9.8 meter per second square, and we know that ax is 0. So that is no acceleration in the x direction. So we have these equations here in the x and y directions. Okay, so we have to use the appropriate equation to calculate the time. So let's use this y equations. Okay, y direction equations. We have yt, y0, v0, yt, half a yt square. So from here we can calculate time. Okay, so let's take that equation and let's take y0 to the left side. Now we have yt minus y0 is v0 yt plus half a yt square. yt minus y0 is 10 meters, right? We know that value. v0y, we already know the y velocity, initial velocity of the ball. We can substitute that. Also, the acceleration is negative 9.8 meter per second. And then the equation turns out to be 10 is equal to 21.2 t minus half 9.8 t square. Now, if you look at this equation, we can just rearrange it into this way. Okay. This is a quadratic equation of the form ax square plus bx plus c equal to 0, where x is t, and a is 4.9, b is 21 minus 21.2, and c is 10. X is t. So we can use the equation to calculate the root. Okay. So calculating the root, that means calculating the value of t. There are two values, you see. Two values we get when we use this equation. So two roots means there are two solutions of the time. Which one we will choose? So one is a small time duration minus 0.54 second, and there's a longer duration 3.79. So the meaning of this is, you see, we are calculating the time when the ball reaches 10 meters above the position, right? So if you look at this curve, the ball reaches 10 meter high 2 times. So one is here, of course. The other one is while going up. Okay, this is while coming down. This is while going up. Here also the height is 10 meters. So the ball reaches here at 0.454 seconds. Then it goes to a maximum height where the y velocity becomes 0, x velocity is still there, which is not changed, and then it comes back. The second time it reaches 10 meter high is here at 3.79 seconds. So we found the answer for the first part. So we have to choose this one. So okay, so the second part, we need to find the velocity, the magnitude and direction of the velocity at impact. Okay, so when you zoom in, you can see that that spectator is catching it at this point. So the velocity is shown as this red arrow, Vt. So Vt is a vector quantity, so we can write as Vt. The velocity at this point is Vxt I plus Vytj. Vx is the x component velocity of the velocity and Vy is the y component of the velocity. So x component and y component. But we know that x component there is no change because there is no acceleration in the x direction. So the value remains same, 21.2 meter per second square. But we don't know what is Vyt, which we need to calculate. Okay. So once we know Vx and Vy, we can calculate the magnitude using this equation. Okay. We are root of Vx square plus Vy square. And also we can calculate the angle using the equation. Theta is tan inverse Vy by Vx. So let's find out. So we need Vyt. To calculate Vyt, let's use the first equation in the y direction. So we'll write it here as Vyt is equal to V0y plus Ayt. Now you know V0y is 30 sine 45. We can substitute that value. Ay is minus 9.8 meter per second square. And time is 3.79 second at this point, right? So here, calculating that Vyt is minus 15.93 meter per second. You see, this quantity is negative because it is directing down. So let's take this value. So we know Vx, we now calculated Vy. So the in vector notation, the velocity is actually represented 21.2 meter per second I minus 15.9 meter per second J. Now what is the magnitude? Magnitude is Vx squared t plus Vy squared t. So substituting the values of Vx and Vy, you get 26.5 meter per second. The last part is to calculate the angle is tan inverse Vy by Vx. Substitute the values of Vy and Vx, you get minus 36.9 degree. That means the angle is measured downwards in the clockwise direction from the positive x direction. So this is the angle.